Okay, so I'm glad to see you all members of the IConMaSTEd conference. It is 15th conference, it is 15th years conference. We have 4 part of conference. Our section is physics and astronomics educational. Parallel of us works session about science, or I'm sorry, computer science education, and in the Friday working chemical, I'm sorry, yes, chemical other conference. And today from 15 o'clock we start South conference, another session, mathematics. So you can be presented on our section, and after our conference we are glad to see you in the next section. And I don't know, journaling maybe not very good time for you.
Yeah, it's okay.
It's okay. Okay, thank you. And Friday, it's also our conference was an evening.
Yeah.
But if you can, we are glad to see you also.
Yeah.
Okay. I think you have a good time for today. I am wishes good luck, all of us. And today in the our section we have 7 topic. We can listen all of us, but I can't all. Irina Sergeyevna, what about other members?
I think they will be later.
Okay. Okay.
Okay. I'm Irina Minci, and I'm a candidate of pedagogical science, and I'm also to present everyone participants of our conferences. Our conference has a rich history, but today I want to focus on the present. Today we have 4 sections about this Svetlana Leonidovna talked, and our geographic of our participants is very interesting. We have 4 articles from Ukraine and 3 articles from Philippines. I'm very glad and each presentation will take about 15 minutes. Microphones for all participation, for presentation, for during the video. Are requested. And now I proposed to take a group photo.
Okay.
Oksana Volodymyrivna, please, and
Turn on
Olga,
your camera if you can. Okay, thank you.
thanks. And Olga Volodymyrівна.
Okay.
Few seconds. Thanks. And we have the first authors. And now
Good afternoon.
Have a good day. And good luck for all of us.
Yeah.
and the second photo. Later we will be to write the article for our site, and this is the first article in conference paper. It's very neat.
Yes. So you can give questions for all of us for all of presentation after the videos. If you can't ask with microphone, you can write in the chat. And please be activity.
And I think we can to start. Yes?
Yes, maybe. There are first speaker. It is speech because and using open experimental data of the European Organization for Nuclear Research in the process of studying the physics, elementary physics. And you can see a video, okay?
The European Organization for Nuclear Research, known as CERN, is an intergovernmental organization that operates the largest particle physics laboratory in the world. Many activities at CERN currently involve Operation the Large Hadron Collider and the experiments for it. In 1 second, the LHC has 600 million collisions, which corresponds to 1 million gigabytes of raw information. With the help of special software, this data is converted into readable objects and stored for further analysis. More than 12 petabytes of new data are generated each year through ongoing experiments, helping CERN scientists advance science and answer questions about the fundamental laws of nature. An important fact for our study is what the European Centre for Nuclear Research report, the discovery of a huge amount of data obtained at the Large Hadron Collider. It is noted that some data are presented in raw form, which they are available to CERN researchers. Other information is presented in a processed form, which makes it suitable for use, in particular for educational purposes. Both students can use valuable information and professional scientists involved in elementary particle physics. The CERN Data Open Data Portal is an access point to a growing range of data generated through research conducted at CERN. It distributes saved results from various research activities, including the accompanying software and documentation that is needed to understand and analyze the data. In this regard, the questions arises of the effectiveness of using CERN open data in the process of conducting practical work in elementary particle physics as one of the methods for generating knowledge about experimental methods for studying modern elementary particle physics. In our work, we use data from a compact muon solenoid. The compact muon solenoid experiment is one of the two large general-purpose particle physics detectors built on the Large Hadron Collider at CERN. Validation compact muon solenoid open data is through successful reconstruction of the J-psi, Y and Z Dc channels for comprehensive statistics. Although they cannot directly observe the particles formed in the collision, where Dc products leave signals in the CMS subdetectors. Special software uses these signals to reconstruct the Dc products, which scientists classify into different families and physicists call physical objects. CMS learning resource is a collection what includes learning resources with the public CMS data. The items in this collection are suitable for educational purpose. For training purposes, complex raw data is processed in the format of simple event visualization programs, histogram, and training resource. To work with the programs, you must have constant access to the internet. Visualization of events takes place in a specially created environment, the event display. The CMS event display, iSpy, can be used to visualize collision data. In the first lessons, students get acquainted with the device and the principle of operation of the muon detector. Main measurement tool, computer program, event display iSpy. Students are to examine DCs involving muon pairs and determine which events are J-psi meson candidates and then construct a histogram of mass counts for events that pass the purple trigger. Consider examples of tests offered to students in the course of the practical work. To be a candidate for J-psi, an event must have two muon tracks of opposite electric charge. In two tracks deviate in the same direction inside the solenoid located inside the hadron colorimeter. They have the same sign, therefore they are not created as a result of the J-psi DC. Next test, opposite charges, quality of the muon tracks. If two muons pass the charge test, analyze the J-psi probability by evaluating each muon track. If there are more than two tracks, rate the two most successful with the opposite charge. Record the score for each event in the datasheet. Calculation of the mass will become possible only after the evolution of muons. Next, the student is advised to count how many events in her set resolved the same scores. Compare the results with other students. If the numbers differ significantly, discuss your scoring criteria and see if the scores need to be adjusted. At the stage of ascertaining experience, there was a study of methodological approaches to practical work in elementary particle physics. In particular, the work of students in studying the methods of experimental particle physics was studied. At the research stage, a starting experiment, training, and control were carried out. The effectiveness of the developed approach was evaluated based on the calculation of the coefficient of efficiency of mastering physical knowledge, determined by the formula of the slide. The main goal of the formative stage was to test the effectiveness of the proposed developments for the workshop in elementary particle physics. By the structure of student learning outcomes, the non-parametric Mann-Whitney U test was used to assess the difference between two small samples in terms of the level of the attribute. From table, it can be seen what were in a larger rank amount in the experimental selection. According to the table of critical values of the Mann-Whitney criterion, students of the control group are inferior to students of the experimental group in terms of the coefficient of efficiency, of assimilation of physical knowledge, of elementary particle physics. Our research showed what were the opportunities to study the operation of the mass technology device in the world, the Large Hadron Collider, due to the opening of access to a huge array of data obtained at the Large Hadron Collider and the development of information, the communication technology. The exploratory and experimental verification of the research results proved the expediency of the practical implementation of the developed methodology for the use of CERN services and data in the process of studying the physics of elementary particles. Thank you for your questions. We will be grateful for your questions.
Okay, thank you, Andrei, for your presentation. Okay, are there questions?
I have questions,
Okay,
and I think this research is very difficult, and it's my opinion. And I want to do these questions. How can we participate in a master class from CERN?
Thank you for your questions. I think studying nuclear physics is very difficult, especially laboratory work, because it requires very special equipment with what is very complex. We have the opportunity to work at a line accelerator, what is relatively close to our university, but it is often difficult to arrange a trip. And the use of open CERN experimental data allows students to be involved in the study of real data from the Large Hadron Collider. And it is much more interesting than computer simulation. Usually each year in spring, research institutes and universities around the world invite students and their teachers for a day-long program to experiment live at the front of basic research. These international master classes give students the opportunity to be particle physics for a day by analyzing real data from CERN Large Hadron Collider. We are planning to participate as well. Thank you.
okay.
How do we think can we implementation the results from to secondary school or not? Few elements.
The simple elements.
Simple elements. about collider, about calculation, about software. Maybe someone or not.
Yes, it is possible. Yes, in the master classes to the center high to the STEM, high school students take part, and secondary school students take part. It is possible. It is possible. And this can be seen on the CERN website.
Thanks. And I have also other questions. Did the students express a desire for further research into the data from the large collider detectors?
Yes, some students expressed a desire to continue exploring CERN open data. This is an interesting topic for example, for the master studies in physics.
Okay. Okay, so I understand this is program, we can use it also when distance learning or on
Yes.
online, yes. Do we need something specially programs or applies, or there are, or we can use the simulation? Are there any?
We used data from compact muon solenoid, but it is possible to use data from other detectors. It's possible, others and other.
Okay, yes, I understand. Thank you. Okay, and what subject? Oh, not subject. You use it this date for the only physics students, or it might be for other specialty. But I don't know who.
It's
Chemical.
only future teachers or not.
Oh no.
Not?
No.
Only for physics students, which is a study for physics teachers.
Yes. So the student needs something knowing from physics. Yes.
Yes.
Physics, informatics, programming, computer.
They will study physics and computer science.
Okay. Thank you.
Thank you very much.
Maybe someone.
Yes, it is very interesting topic, because really our students need scientific in the educational process, and also if it can be used in the secondary school, maybe for future science junior works.
Yes,
Junior science work. Yeah.
Yes.
Maybe there are any questions?
Hello, can I ask?
Yes, of course.
Okay. Uh, can you share to us or to me how is the process of getting the permit, or how did you the access of the data? Is it easy for us to access data from CERN to make it usable to our students so that we can also perform? Actually, I am teaching modern physics. A part of it is elementary particles or particle physics, just an introductory. However, it is very hard for us to I mean, I encounter difficulty on how am I going to, the practicality of this experiment to students is very hard, no, because because it is only for big university or laboratory like CERN. So if that's the case, that we can access the data from CERN for educational purposes, are we going to seek, or is there an open access for this data so that we can also use this for our students' experiments? Thank you.
Thank you for your questions. I think what access to open data is open to anyone.
Okay.
We recommended what you join. Grab, processed, and well visualize data, and there are raw fast data and processed data where you can find and make a real discovery. But there is a lot of data, very big data, and you need to write a program for neural network, I think.
Okay, thank you. So I'll be maybe in the future, I'll be also doing those or that kind of experiment in my class. Thank you.
Thank you. Good luck.
Questions? Okay, thank you, Henri. And we go to secondary presentation. It will be from Philippines. Jodelyn Ladera Patero, and she presented first report design and fabrication on an improvised Young's modulus Apartanus.
Good day, everyone. My name is Judilyn L. Patero from Northeastern Mindanao State University, Cantilan Campus, Surigao del Sur, Philippines. My talk is entitled Design and Fabrication of an Improvised Young's Modulus Apparatus. So Young's modulus is a fundamental concept in physics, and teaching this concept needs apparatus that allows a student to perform actual experiments rather than reading, because this could enhance students' curiosity and eventually improves their class performance. However, acquiring laboratory apparatus for this purpose remains a challenge in the basic education and even in the higher education level, especially to countries like Philippines, because these are very expensive, like the ones distributed by Fisher and Pasco Scientific. In the Philippines, it takes months and even years to acquire such apparatus due to the state procurement procedure that we have, since such instruments can be purchased only from outside of the country. So to help aid the challenge of unavailable and expensive laboratory apparatus, particularly in the demonstration of elasticity of matter, fabrication of this apparatus was conducted. This paper presents the design and fabrication of an inexpensive improvised apparatus used to determine Young's modulus of selected metallic wires. For the methodology, so these are the materials and devices used in the fabrication. The dimension of this apparatus is 132 cm by 10 cm, and the required power supply is 3.6 volts. These are also the salient features of the apparatus. So figure 1 is the apparatus assembly. Figure 1B is called the sensor contact, and this serves as an extension to the pulling arm of the spring balance. Sensor assembly is also consists of contact sensor indicator that lights on if the sensor contact touches on the thimble of the micrometer, and a micrometer caliper where you can read directly the elongation. The tensioner assembly showed in figure 1C is also consists of improvised spring balance that provides load to the Young's modulus apparatus and a spring holder that can be adjusted according to the desired load. And figure 1D is the test wire anchor. So these are the method in the construction and fabrication procedure. So after the fabrication, we tested the apparatus manually using 3 different metallic wires. The testing is done in a normal classroom condition with no control over humidity. The apparatus is not temperature sensitive, and the data accuracy for all the measurements is plus minus 0.05 mm. So we tested using 3 metallic wires, one for copper that is 0.42 mm, GI wire of 0.555 mm, and the stainless wire that is 0.42 mm. And for copper and GI wire, it really shows linear relationship between the load and the elongation. However, for the stainless wire in figure 2B, the elastic behavior is only from 400 grams to 800 grams, and after that the elastic limit has been reached, and we have that in the upper part, the inelastic deformation. So in determining the experimental value of the Young's modulus for these metallic wires, we use the principle of least squares and then compare it with the standard using the formula here. And we can also show or calculate the experimental value of the Young's modulus as given by the equation also below, where the slope is, or where the Young's modulus can be expressed as 1 over the slope, that is 12.5 d squared times y, and then multiplied by 12.5 over d squared. And using the above equation, for the calculation of the modulus, we summarize the values of this in the table 1. So we have this table, and then the percentage difference is also calculated using the equation below. So in conclusion, data proves that elongation is directly proportional to the load, analytically proves that the proportionality of the stress and strain is the Young's modulus. The fabricated simple and inexpensive Young's modulus apparatus is simple and consists of relatively inexpensive off-the-shelf material. It actually minimizes the computation that in many instances also proves to be deterrent in the understanding of the concept. It is very versatile and easy to build. It is excellent for high school and even in the tertiary education or level, and best for classroom demonstration. So this can also be used in introductory physics laboratory experiment. Thank you. So good day.
Okay, thank you, and for you. Yes, it's a traditional question. Yes, are there any question, member? Start another members of our conference. Okay, I am sorry, maybe I don't layer. What material do you use it? Do you not use it? Do you use it for experimental with
Uh,
student?
the students, I use the secondary high school, the secondary
Okay.
students, yeah. But for
Uh,
science curriculum
oh,
students.
okay. And what material do you experiment? Use it for experiment? Material of mm, because it's a very interesting uh, interesting construction. Use it on the for the students. Are there any big or any very expensive?
No, it's not. It's
No,
not
it's not.
expensive. Yeah, it's not just that. It's not like those that can be buy from from Pasco, for example, or from Fisher, that it's very expensive. So the term is off the shelf materials, and I do it in the laboratory also. And in the laboratory, we have the machinery. So the in charge there were able also to help me in the construction of the project.
Okay, so we need especially laboratory for do it another.
Yeah.
Okay, yes, I understand. Thank you. And we have question on chat. Thank you for the interesting report. We are doing research in biophysics. So I want to ask if it is possible to use your device to find Young's models for organic biology
But
materials.
yeah, why not? But I was not able to test this for biological materials. However, we can, if if uh if given the chance, why not work with this biological materials with you? I would also be glad. Yeah.
Okay. Thank you.
I want to talk about the situation with physics education in Philippines.
Philippines.
And now in Ukraine, this situation is critical,
Not very, very good.
not very good. We have a low knowledge of students, and a few students enter to pedagogical university. What is the situation in the Philippines now? In the secondary school, in the high school?
Okay,
What do you
so
think about this situation?
in the Philippines right now, I could say that because we are far from Metro Manila, yeah, it takes an hour for the capital, shall we say, the Metro Manila is about an hour and a half from our place. So we are in, shall I say, rural something. Yeah. So that is why in our place, as I have talked to the secondary teachers, especially in the basic education, they are still actually lack with these scientific instruments. Yeah, and even instructional materials. And then also, because this is a common problem to us. And then also, if we want to buy, no, so the procurement procedure in our place is, especially in the government, is like it takes year or like like 6 months to 1 year to acquire this kind. So teachers are actually doing some like initiatives just for their students to learn the concept that they are discussing. Just a shall I say it, the teachers finds way to have some alternative like instructional materials that they can do at their own, so that students could understand the concept that is being taught. So it's hard. It's the it is very difficult to acquire, especially scientific instruments. So because we believe that these scientific instruments could also enhance the learning capacity of the students. So this remains actually in the rural area. This remains a problem. Not all secondary schools can afford and have this luxury of instruments that they want. So still it's a problem. Yeah.
Okay,
And,
thank
and
you.
other questions. How do teachers from university cooperate to a secondary school? And how do teachers from secondary school cooperate with high school?
Okay. In how will I say it? In the learning, in terms of knowledge, we have actually like one of our mandate of one of the fourfold function of the faculty in the university is to extend and then extension, like an extension program. We have an extension program for the secondary schools. So we help them. So in terms of knowledge, we have some workshops, and then like for the teachers, we conduct seminars. We address the gap in terms of knowledge. And for students, workshops. And then it's a form of extension activity actually. Because we also reach the need, we also reach out these secondary high schools in terms of their need, especially for schools like because the secondary schools in the Philippines, in the government, has different curriculum. So for instance, if they are offering STE, so there we can help through our extension program. I hope it is okay.
Okay. Okay, thank you. Yes, because in Ukraine there are very big problem when teacher don't between teacher lecture and between secondary and high school. We need more communication. So thank you. Are there any questions?
We have a chat.
No.
Can I also add to Judeline's answer, since I also come from the Philippines? It's Ivan Kulaba. Maybe yes.
Yes.
I would just like to add more to what Jodeline said regarding how the university, higher education also help the secondary teachers. Now, I come from Ateneo de Manila University. I am connected with the Department of Physics. My colleague here is Ramon de los Santos, and we have been actively engaging with high school physics teachers in a city near our university. And if I, we develop simple materials, equipment, which we use for training teachers, similar to what Jodeline presented. So we have a physics education resource center where we do trainings as well as develop materials for secondary schools. Thank you.
Thank you,
Okay,
sir.
thank you, NGO. Okay, thank you. Okay, and we go to next report, yes? Okay, next report, we also from Philippines, and main speaker also Judeline, but authors are say the teams, да? Small teams. Topic effect of physics alphabet model on the mean achievement of students' performance. Please.
So good day, everyone. My name is Judeline L. Patero from the Northeastern Mindanao State University, Cantilan Campus, Surigao del Sur in the island of Mindanao, Philippines. So my talk is about the effects of physics alphabet model on the mean achievement of the students' performance. So physics use models of various kinds to aid the understanding of complicated physical situations. This implies that mastery of the physics concepts will only be realized upon using instructional materials. Teaching physics without learning materials will certainly result to students' low performance in the class. A professionally qualified science teacher, no matter how well trained she is, would be unable to put his ideas or her ideas into practice if the school setting lacks the equipment and materials needed to translate his or her competence into reality. In the Philippines, one of the academic environment indices that remained to be a challenge identified was the limited instructional materials and technologies and poor laboratory facilities. Over a long period of time, it has been well documented that students have misconception with the meaning of letters or symbol of physical quantities. Symbols actually are the cornerstone of the written language of physics and mathematics, but if inconsistencies but if there is inconsistencies, it poses a challenge to the students. So to help address the above mentioned challenges, a physics alphabet model was developed as an instructional material to help aid students' performance. So the physics alphabet model is designed to provide an environment for interactive student engagement and enhance system skills abilities. Particularly, it provides less confusion and less difficult for the students to identify and familiarize the notation of the quantity to its symbol and units. For the effects of this model to the students, the researchers used the quasi-experimental design that involves selecting groups upon which a variable is tested without any random pre-selection process. This primarily deals in determining the significant difference in the mean achievements of the students having and without having a physics alphabet model in studying physics. The respondents are a heterogeneous group of students in grade 10 under the basic education curriculum, a regular curriculum under the K-12 program. They were chosen equally to ensure diversity of ideas and opportunities among respondents and were identified at least in the performance of the as least in the performance of physics subjects. So 30 of the 52 students from grade 10 gold and 30 of the 55 students in grade 10 silver were randomly sampled based on their grading in second quarter performance. We have to take note that the sections gold and silver here are just name of the sections and are of the same level of performance. So the 30 students from the two sections were assigned and divided to as experimental group and control group. So the study was conducted at the Cantilan National High School, Magasang, Cantilan, Surigao del Sur, and the development of this physics alphabet model was done at the Science Building, Northeastern Mindanao State University. So the research instrument, the researcher uses a researcher-made questionnaire, which was validated by the experts and consists of a 50 item with only 3 options for every item. And then the formulation of each item is based on the topic discussed before and after the test. The statistical used here is the match paired t-test, and it is an unequal variance where it was statistically analyzed through the use of SPSS software. So data analysis, we calculated the mean, standard deviation, and the t-test statistical tools were used. Scores of the different groups were computed and used in testing the hypothesis. So the level of the significance adapted for this analysis was P equals 0.05. This level of significance formed the basis for or rejecting or not rejecting each of the hypotheses. So for the results and discussion, so we have table 1 here for the mean achievement scores of the students in physics with and without the physics alphabet model. So we see in the table that the experimental group has a mean achievement scores of 9.53 in the pretest and 15.40 in the post-test. So this means that there is an increase in the students' performance with the application of physics alphabet model as an instructional material. So table 2, the paired differences table. So pair 1 implies that there is significant difference at 0.05 level of significance between the pretest and post-test mean scores of the experimental group. This means that the pretest mean score is significantly different from post-test mean score with respect to the utilization of the physics alphabet model in studying physics using conventional method of teaching in the experimental group. And this also implies that using this model has a great upshots to the performance of the students in physics where there was a significant increase on their scores. So table 3 above represents the data between the difference of the average mean from the pretest to post-test of the experimental group, control group, and the experimental control, whereas P is significant at 0.05 level, where C is 2.045. Based on the result, it was found out that there is really a significant difference among the 3 variables, since the t-value obtained of all the variables are p greater than 0.05. Therefore, the result warrants the rejection of the null hypothesis. The researchers accept the alternate hypothesis that there is a significant difference of the students' mean achievement scores in studying physics between experimental group with a physics alphabet model and control group without the physics alphabet model as an aid of instruction. On comparison of the t-value, it reveals that the experimental group is significantly higher in its level of rejection of H sub O than the control group. On the other hand, comparing the post-test between 2 respondents, it reveals that there is also a significant difference noted and implies that integrating physics alphabet model is as an instructional material has its effects on the performance of students in Cantilan National High School. Thus, it increases their mean achievement score in physics. In conclusion, the modified physics alphabet model was effective as an instructional model where it increases students' mean achievement in the class. There is a significant difference of the students' performance in studying physics between experimental group having a physics alphabet model and the control group without applying the model as an aid of instruction. Thank you for listening.
Thank you, Jodolink. It's very interesting experience. And maybe I ask first question. If I understand, you used physics alphabet, yes?
Yes.
Okay, what it's very interesting because I have a student which asked me how I can study physics when you use it as the same literature for different physical parameters. What about T, temperature, time? No, for example, in Ukraine, it's make T or period.
Yeah.
We make T.
Mm,
What about you do with the same problem? Oh, it isn't problem.
At first, it's really a problem. So, because our students here, especially in the basic education, has the difficult in identifying if that symbol is used for this parameter or this quantity or what, or is there or can we exchange the notation or what. So the same problem with you actually. That is why we try to develop our own version of physics alphabet model to for the students, you know, to easy understand and then identify the notation so that when they reach college, for example, or even in the college, no, in the introductory physics, some students has also this difficulties encountered in identifying. So we do this, we develop this kind of material.
Okay, thank you. And next question is the same maybe. When you use it alphabet for experiments, do you use it for one themes or all course of physics, from electric, mechanics, optics?
For mechanics, thermodynamics, mechanics, thermodynamics, optics, and electrodynamics.
Electricity. Okay.
Yeah.
All together. Or
Yeah.
yes. Okay.
Yes.
Thank you. Thank you. It's very interesting, expensive because it's really a problem for in the secondary school.
Yeah. That's why.
Yes. Yes. Thank you. Are there any questions? Because
I want to ask
okay,
following. I see this research is completed, and is this your individual research, or maybe part of a grant or a program? What about this?
The fund of this study or project is from our university. This is actually for my students. They do this. Yeah. But just a minimal amount of the fund given to the students. So the university or our university is also helping our students. They give a small amount for the to do their study or their project. Yeah.
Okay.
Thanks.
Okay. Thank you.
Maybe
It's
let's go.
Yes, it's very interesting, and I think we also can use this experience and this program. Maybe in this, yes, maybe in the secondary physics course in the universe.
Yeah, you
Okay,
can.
thank you.
Thank
Okay,
you.
thank you for your presentation. And next presentation from Ukraine, teams from the State University of Trade and of Economics, and speaker Oleg Pursky about laboratory equipment for practical learning in the framework of educational course Molecular Physics and Thermodynamics. Please.
Good afternoon, everyone. I am Oleg Pursky from State University of Trade and Economics. Dear colleague, let me present to your attention the result of our research on the topic laboratory equipment for practice learning in the framework of educational course Molecular Physics and Thermodynamics. In physics education, an extremely important factor as it determines their learning quality is the process of forming students' practical skills through experimental research. The performing laboratory work, students learn to use physical devices as a means of experimental research, which together with theoretical learning provides a basis for a full understanding of physical process or phenomena. An important stage in the development of intellectual education scientific abilities of students is not only the study of theory, but also the implementation of the theory in practical activities. Therefore, modern methods of teaching physics foresee the involvement of students in such types of educational activities that allows to use the acquired theoretical knowledge in the practice, in particular to perform laboratory work by students. The modern course of molecular physics and thermodynamics present rather complex theories that require experimental verification for a better understanding by students, in particular transfer process and kinetic phenomenon in liquid phase transition, isobaric and isochoric, adiabatic, and other thermophysical processes. In this study, we present developed laboratory equipment for practical training, in particular experimental research of temperature dependence of heat transfer process in molecular liquids under isobaric condition, and describe the procedure for its use. Temperature dependence of thermal conductivity are investigated as a rule along isobars and isochores. At the same time, it should be noted that various experimental methods were used to measure thermal conductivity coefficient, in particular linear flow state method and radial flow steady state method. The stationary methods are simpler and more reliable since they are based on direct measurement of thermal conductivity. One general conclusion can be drawn from the considered experimental method of measuring thermal conductivity coefficient. None of existing method of measuring thermal conductivity can ensure 100% distribution the controlled heat flow through the sample, only due to its thermal conductivity. There are always processes that affect the measured values of thermal conductivity coefficient, thus introducing significant error in its value. Therefore, when choosing one or another measured method, it is necessary to take into account the specific of scientific task, take in account the temperature range of the study, the pressure range, and the characteristics of the substance under investigation. The study to study the isobaric thermal conductivity of liquids among the stationary experimental method, the most successful constructive solution from the point of view of minimizing the influence of additional factor on the process of measuring thermal conductivity coefficient is the radial flow steady state method with the coaxial geometry of measuring cell. The peculiarities of the thermal conductivity measuring method for liquid put specific requirements both on conducting the experiment and on the measuring equipment itself. For this purpose, laboratory equipment was created for measuring isobaric thermal conductivity of liquid. The general decision scheme of the installation is shown in Figure 1. The created experimental technique uses general decision solution of the coaxial cylinder method, preserving its features and measurement precision in general. The installation allows measuring the coefficient of thermal conductivity of liquids under atmospheric pressure and saturated vapor pressure in the temperature range from 115 to 400 kelvins. Cooling to below room temperature is carried out to the use of removable cooling conductor, see Figure 1a. When placing the cooling conductor in the transport drawer, its lower part is in contact with the liquid nitrogen. The measuring cell construction is shown in Figure 2. It consists of two coaxial geometry cylinders between which the liquid under study is located. The measurement cell was produced from the cooper. Along the axis of cylinder 1, a hole is drilled from or pressed in the invalid tube 2, made of stainless steel. The liquid samples vary between outer 1 and inner 3 cylinders. Liquid have small thermal conductivity coefficient 2 or 3 orders lower than the thermal conductivity of metals. With such construction of measuring cell, the thermal resistance of the metal layer of the inner cylinder 3, which occurs between the liquid and the internal thermometer 7, and the boundary capital thermal resistance on the outer 1 and inner 3 cylinders, in comparison with the thermal resistance of the liquid sample layer, can be ignored. The use of one thermometer during temperature gradient measurement made it possible to avoid the influence of unaccounted heat flow and the difference in the calibration of thermometer on the value of thermal conductivity coefficient. With this method of measuring thermal conductivity, the maximum possible error in thermal conductivity values associated with unaccounted power losses of the interval reactor 5 due to thermal radiation does not exceed 0.2%, with a temperature gradient of no more than 0.5 Kelvin. The reliability of laboratory installation was determined from a series of preliminary experiments on measuring the thermal conductivity of exemplary liquids. None, toluene, and ethyl alcohol were chosen as template liquids which were studied in data. The main factors that depend on the correctness of the thermal conductivity coefficient measurement by the radial steady state method are occurrence of the temperature gradient determining and stability of the measuring cell temperature during the experiment. In this installation, platinum-resistant thermometer with sensitivity to temperature change 0.0005 Kelvin are used to measure temperature and temperature gradient. The accuracy of maintaining a constant temperature of measuring cell is no worse than 0.005 Kelvin device hour. The measurement error of liquid's thermal conductivity coefficient does not exceed 3%. With the help of created laboratory installation, it is also possible to measure thermal conductivity coefficient in the temperature areas that correspond to pre-crystallization temperatures. The thermal conductivity coefficient calculated using Formula 1. The parameter and their characteristic. The parameter that included in Formula 1 and the characteristic presented on this slide. On this slide, you can see temperature dependence of platinum-resistant thermometer that used in calculation of thermal conductivity coefficient. Developed laboratory equipment has certain features and advantages compared to prototype. Firstly, it is a wide range of temperature for measuring thermal conductivity. And secondly, it is compactness and economy in the use of the investigated substance and coolant, liquid nitrogen. The main features of developed equipment is the cooling mechanism of the cryostat by immersing its lower part in the transport device with the liquid nitrogen. Such a cooling mechanism provides a significant saving of crude liquid and allows obtain a constant temperature of the cryostat external environment in a fairly simple way, which is an important factor in stationary method of measuring thermal conductivity, in particular in the procedure of stabilizing the measuring cell temperature. Conclusion. Measuring the thermal conductivity of molecular liquids is associated with a number of difficulties, among which the following can be highlighted. Ensuring the measurement process in the low temperature range, ensuring free expansion of the liquid inside the measuring ampoule when its temperature increases, minimization of health losses due to high radiation, uncontrolled heat flows, ensuring the necessary accuracy of measurements. The present laboratory equipment for measuring isobaric thermal conductivity of molecular liquids allows positively solve the mentioned problem. The use of measurement of the thermal potentiometer method allows to avoid the error arising in the values of the thermal conductivity coefficient due to uncontrolled heat flow and different calibration of thermometer, and significantly increases the measurement accuracy. The created equipment for measuring thermal conductivity of liquid by stationary method of radial heat flow allows, due to the specific of measurement techniques and the construction features of the measuring cell of coaxial geometry, to avoid convective heat transfer. The presented laboratory equipment will be useful for forming practical skill for physics specialty students. Thank you for your attention.
Okay, thank you, Oleg, for your presenting. Dear colleagues, are there any questions? Yes, It's a very complex illustration, and this is a serious and long work. It's a really important work for our term, no? Nowadays, it's very useful, and we very needed new instrumental for our laboratories. Okay, maybe any questions?
Maybe I add.
Yes, okay, you can something adding. Yes, Alex, please.
The presented laboratory equipment can be used not only for laboratory work, but presented laboratory equipment can be used for scientific research. For example, as an example, I can see some scientific work that published in scientific journal, and the result and the result that presented in this scientific research can be used for creation now theoretical prediction in course of thermodynamics or molecular physics.
Okay, how long do you eat instrumental? How long?
How long?
And I'm sorry, and you do it often, or it's a very big team?
For creation of this laboratory equipment, we used in we used some prototypes, and it's collective work of our teams from faculty, from Department of Molecular Physics of Taras Shevchenko State National University.
Okay.
And a student of master degree can use this equipment for qualification work.
Okay. Yes, it's
about patent your device.
No, we haven't patent, but this construction published in a journal Low Temperature Physics from American Institute of Physics.
How much your device costs? About.
expensive or cheaper?
How? So repeat question. Repeat questions, please.
How much it costs?
How much it cost? Oh.
Или zero?
Sorry.
Which zero?
Which zero? How much it cost? No, I think this laboratory equipment and I don't understand your questions. Can you in detail formulate your questions?
Irina ask you how much cost, is it expensive, your instrumental? Okay.
Without details.
Скільки коштує?
it's a difficult question because for creation laboratory equipment we used many detail. For example, platinum thermometer. It's very high cost help, and for example, some data we created by our teams, and what price of this data I don't know.
Okay, I ask another. As you think, in our university, we can do it the same instrumental or not? We haven't a special laboratory.
Yes, you can use this laboratory equipment for in other university, but in for students or for departments of physical faculty. Yes, and for use this laboratory equipment, you need needed resource of liquid nitrogen for cooling this cryostat. Liquid nitrogen, you have a plant for cooling liquid nitrogen. You can use this installation. If you haven't plant that created liquid nitrogen, you can't use this installation.
Okay. So yes, I understand. Thank you. It's very interesting, and as we say, it's a very important for students because it's also for students for future teacher of physics, because they didn't any scientific works. Okay, thank you. Are there any questions for Oleg? Okay, then next report, it's from the Minia University, Ramon Deltos Santos, and topic fabrication of and application of novel and multi-future spectroscope. We continue about the new instrumentary. Okay.
Hello and good day. On behalf of my co-authors, Mr. Ivan Kulaba and Dr. Joel Makiling, I am here to present our study on the fabrication and applications of a novel and multi-feature spectroscope. My outline of presentation will be as follows. First, I'll give a brief introduction to an optical device known as the spectroscope. Next, I will walk you through the major steps in fabricating the spectroscope and acquiring the emission, transmission, or absorption spectra of different samples. Then, I will highlight some notable results of our study, including the emission spectra of 2 light sources and the transmission spectra of thin green leaf and a dissolved chlorophyll sample. Finally, key takeaways will be articulated in the summary and conclusion. The main objective of the study is to develop a locally produced teaching instrument using indigenous materials as promulgated by the Philippines Enhanced Basic Education Act of 2013. In particular, this research aims to fabricate a multi-feature spectroscope that allows simultaneous observation of the emission spectrum of a light source and the transmission or absorption spectrum of transparent solid and liquid samples. In general, a spectroscope is an optical device that can stimulate students' interest in the visible light's constituent colors. These educational tool is conveniently used to qualitatively observe the emission spectra of various light sources. The basic design of a spectroscope, as shown in this figure, consists of a tube or box with fixed caps at both ends. At one end of the tube, the cap has a slit where the light enters. The cap on the other end of the tube has a grating over a small hole for observing the spectrum. Through the objectives of our study, we were able to form a research question. Particularly, we wish to investigate how can a simple spectroscope be modified to allow the simultaneous observation of the emission spectrum of a light source and the transmission or absorption spectrum of transparent, solid, and liquid samples. In this study, we used the commercially available cylindrical coin banks made of hard cardboard and with black plastic end caps. The leftmost figure shows two sample coin banks with their opposite end caps. The magnetic sheet with a slit hole is later on mounted on the topmost cup. Hence, the rightmost figure shows the topmost cup with the magnetic sheet, and the other cap with the grating mounted over the observation port in the form of a small hole. The magnetic sheet placed at the entrance slit provided useful features not found in a typical simple spectroscope. As shown in figure A in this slide, razor blades can be attached to the magnetic sheet to vary the slit width. Furthermore, we note that in figure B, a thin green leaf mounted with two steel strips can be conveniently used as a sample for observing transmission spectrum. And as shown in figure C, a cuvette with steel brackets can be easily attached for investigating transmission or absorption of colored liquid samples. In this study, we demonstrated the capability of the fabricated spectroscope by acquiring the emission spectra of various light sources. I will be presenting 2 out of the 4 light sources considered in this research. Shown in this slide is the emission spectrum of the compact fluorescent lamp, or CFL, as viewed from the spectroscope and recorded by a mobile phone camera. Note that the fluorescent light gives discrete Roy-G lines as confirmed by the spectrometer data shown in the rightmost figure. Meanwhile, the emission spectrum of a helium discharge lamp in this slide shows its unique fingerprint lines of red, yellow, green, and blue, as shown from right to left. The helium discharge lamp emits more prominent discrete lines as confirmed by the spectrometer data and also shown in the rightmost figure. Note that the shaded area in the spectrometer data are the only ones recorded by the mobile phone camera. In this research, the acquisition of the transmission or absorption spectra of a thin green leaf and chlorophyll extract highlights the integration of concepts and principles in physics, chemistry, and biology. It can be used later on as a springboard for multidisciplinary discussion on the subject of photosynthesis. In this figure, the upper half of the spectrum image shows the visible spectrum of sunlight, while the lower half is the light transmitted through the thin green leaf. Based on this figure, it is evident that the red and blue colors of the spectrum have been efficiently absorbed by the green leaf, consistent with previous studies involving photosynthesis and chlorophyll. In this slide, as shown in the leftmost figure, observing the transmission or absorption spectrum of the chlorophyll extract allows for a complementary discussion on which component of the green leaf absorb the said colors. Note that this spectrum is very similar to the one obtained from the experiment involving the thin green leaf. So the topmost graph on the right shows the absorbance spectrum of chlorophyll dissolved in 70% isopropyl alcohol, which is obviously dominated by the blue and red colors of the spectrum. Corresponding transmittance spectrum is also shown in the rightmost figure, consistent with the lower half of the spectrum as viewed from the spectroscope and recorded by a mobile phone camera. From this set of data, we can conclude that a multi-feature spectroscope was fabricated with a magnetic sheet, which allowed the slit width to be easily adjusted and conveniently hold transparent solid and liquid samples. The spectroscope was used to observe the emission spectra of different light sources. Furthermore, the device was utilized to simultaneously observe the emission spectrum of a light source and the transmission or absorption spectrum of solid and liquid samples. Finally, we note that this optical device is useful for both students and teachers in the STEM education subjects, such as physics, chemistry, and biology. Finally, we would like to note that this work was supported by the Action Research to Innovate Science Teaching, or ARTIST project, which was co-funded by the European Union under the program Erasmus+, Capacity Building in Higher Education. Special thanks also to the Ateneo de Manila University for the conference subsidy. Here are the references highlighted in this presentation. Thank you for listening. We are now open to any questions and comments that you may have. Thank you very much.
Thank you, Ramon. It's very interesting instrumentary, and it isn't very big, so all students can use it for their experiments. Yes.
Yes.
Do you use it? Do you have very many such instruments, or only one?
First of all, I would like to acknowledge my co-authors, Sir Ivan Kulaba and Dr. Joel Makiling, who are also present this afternoon or during the presentation. My answer is yes, we have several of these devices. So currently,
yes.
Sir Ivan is showing you some samples of these devices. And we would also like to note that this spectroscope is just one of the several improvised devices that we have currently in the physics education research lab in the Ateneo de Manila University. And perhaps Sir Ivan can add to that.
Okay, yes, this device we can use it and for students for high school and secondary school. And it's very interesting because students don't understand what is the spectrum. And we can't small instrumentary for demonstrating this. Okay, thank you. Are there any questions, dear colleagues? Maybe Ivan can add something adding. No, Irina, please.
I remember that last year you took part in our conference, and last year you was device 2. What about future in the next year?
Next device.
Yes, well, I would say that my experience last year is a positive one, and so I encourage my colleagues from the department to also join the conference. And hopefully, yes, I'm planning to join the conference next year. Hopefully, I can bring in my undergraduate students who are currently working on their undergraduate thesis. I can't reveal the projects yet, but definitely it will be on improvisation of instruments or devices. Again, harnessing the power of light.
Thank you. So we have the first article for IConMaSTEd and IConMaSTEd 2024.
4. Yes. Thank you. Yes, Anastasia, we need the same advice because in KRYVYI State University we have modern laboratory and we have some instrumentary from Werner. It's one university and the best laboratory in the Ukraine, but the same device we don't have. Because maybe we answer yes, Valery Maximovich, Valery Valentina Mykolaievna, and we study your experience more and more. Thank you. Are there any questions?
Thank you. Sir Ivan, do you want to add other information regarding the
Yes, thank you for your
other
materials.
instruments that we develop?
Okay, yes, it isn't. And I must ask you, are they very expensive or not very expensive? Not? Oh.
Sir,
Microphone.
you're muted po.
Ivan. Turn on microphone.
The instruments that we make are simple because they are for basic education. And the design of these instruments are based on the problems that we see in the public schools.
Mm-hmm.
For example, the spectroscope is easier to use than using a prism for students in high school. So
Yes.
we get a lot of ideas from working with high schools, especially the public high schools.
Yes. It might be in the public lecture, public demonstration. Okay, thank you. We think about it. Okay, thank you. And we continue about mobile devices, about modern device, and next report from the Ukraine, from the KRYVYI State Pedagogical University, and it's small teams, Anastasia Zdeshets and Valery Zdeshets, and speaker is Anastasia Zdeshets, measuring yards man density using IoT technology.
In
Okay.
parallel with the rapid development of mobile applications for smartphones, bring your own device technologies are becoming more relevant in the educational process, when equipment that is in the pocket of a modern student is used in classes. BYOD technology becomes most effective if all students are provided with research equipment. But it is difficult to ensure such conditions in terms of distance learning during the war, the coronavirus pandemics, and so on. In order to solve this problem, it is necessary to be able to develop laboratory installations that each student can make on his own. As an example of the implementation of this principle, the article considers a physical installation and a method of conducting laboratory work, measuring Earth's mean density using BYOD technology. There are three parameters determined in this work: the acceleration of freefall, the Earth's mass, and the mean density of our planet, which will allow physics students, geodesists, surveyors, and others to determine for themselves that Earth has a heavy core. The purpose of this article is to show that the smartphone is a powerful measurement tool that, in combination with BYOD technology, increases student learning opportunities, namely makes laboratory practice not too difficult, provides an opportunity to conduct experiments both in the laboratory and remotely. This makes it possible to solve several important educational problems, in particular, the problem of providing educational institutions with modern measurement equipment, which, due to the constant development of mobile applications, significantly expands the boundaries of the educational process. The first truly accurate measurement of Earth's mean density was made by Henry Cavendish. His result was within 1% of the currently accepted value of 5,515.3 kilograms per cubic meter. The most important characteristic of a celestial body is its mass, which can be calculated by Kepler's third generalized law. The mass of the Earth can also be calculated by measuring the force of gravity on its surface. A student, for example, can determine the mass of the Earth using a mathematical pendulum. If h tends to 0, then from equation 3, we get that freefall acceleration. Many works are dedicated to the measurement of freefall acceleration using smartphone sensors. From equation 2 and 4, we get the formula for determining the Earth's mass. Therefore, to determine the mass of the Earth and its density, we need to make a mathematical pendulum by tying an extensible thread to a ball, measure the oscillation period, the length of the pendulum, and know that the Earth's radius equals 6,371 kilometers. Gravitational constant g, then the Earth's mass is determined as follows. Let's ask the question, what tools does the student have for conducting this physical experiment? If he is at home, modern smartphones have many sensors, and there are a lot of corresponding mobile applications developed. The applications used to perform our laboratory work are Physics Toolbox Sensor Suite and Firefox. These are very convenient applications that include the ability to measure parameters of physical fields using smartphone sensors, such as gyroscope, magnetometer, light sensor, accelerometer, and provide the ability to record results, present them graphically. Thus, the magnetometer sensor measures the strength of the magnetic field along the X, Y, and Z axis, as well as the magnetic properties of materials. Such sensors can be used in studies for the magnetic field and fluctuations of its intensity. The light sensor can be used to study the light level. Summarizing the above, we come to the conclusion that a mobile device should become an everyday tool for learning. In order to determine the oscillation period of a mathematical pendulum using the magnetic center of a smartphone, we must first determine its location. To do this, you need a small magnet, a smartphone with the Firefox or Physics Toolbox Sensor Suite applications, a ruler, and a piece of paper with a 5mm grid. The position of the sensor is determined by using a technology that consists in bringing a small magnet closer to the phone's sensor from different directions and determining the maximum value of the magnetic field induction. The value of the X component of the magnetometer is then equal to 0. The determinant of the Y-axis is also determined using the Physics Toolbox application. Compass determines the position of the magnetic field sensor in the smartphone. For this, the magnet is placed next to the smartphone. If the maximum magnitude of magnetic field induction is displayed, then the magnet is exactly at the level of the sensor. The magnetic field sensor is now located in the intersection of the X and Y axis. As it's seen in Figure 1, the indicators on the display make it possible to determine both the magnitude of the Earth's magnetic field and calculate the angle of inclination of the magnetic field induction vector by compass Y and Z. The iron ball of the pendulum most often stays at the state of rest and is magnetized under the influence of the Earth's magnetic field. The magnetization of the ball in this lab is used to measure the period of oscillation of a mathematical pendulum. An iron ball with a diameter of 52 millimeters on a thread with a length of 710 millimeters was attached to the tabletop with a binder clip. The length of the pendulum equals 0.736 meters, which corresponded to the theoretically calculated oscillation period, which equals 1.721 seconds. The magnetic sensor of the Huawei P20 Pro smartphone was used as a sensor which was placed under the pendulum ball at the 0 mark. The measurement of the change in the magnetic field near the sensor during the oscillation of the ball was carried out using the mobile application magnetometer by Firefox. The view of the display during the experiment is shown in Figure 3. The actual measured oscillation period was 1.71 seconds. Another method of determining the oscillation period of a mathematical pendulum is the video registration of the movement of the pendulum ball in the slow motion mode with simultaneous time registration. Such a video is launched with the usual frequency for mobile phones of 30 frames per second, allowing to show the video slowed down by 2 to 32 times. So the processes that were previously invisible to the human eye are open for measurement now, and it is more convenient to do this if there is a time fixation of the event. The stopwatch mobile application was used as such a clock with a time measurement accuracy of 1 millisecond. The algorithm for determining the oscillation period consisted in measuring the time interval t during which the mathematical pendulum made 10 oscillations. The mean oscillation period of the mathematical pendulum for 10 experiments was equal to 1.725 seconds. Another method of determining the oscillation period of a mathematical pendulum is the method that uses the smartphone's light sensor. To do that, select the illumination option in Physics Toolbox mobile application. The oscillogram of oscillations of a mathematical pendulum recorded by a smartphone is shown in Figure 5. The mean period of oscillations of mathematical pendulum for this method for 10 experiments was equal to 1.750 seconds. So, the oscillation periods of the mathematical pendulum, determined using various methods and smartphone sensors, are shown in Table 1. The data presented in the article are the average data of the result of measuring the Earth's density by a group of physics students of a pedagogical university in distance mode. All students coped with this task on time and without difficulties. Thus, there are 3 ways to measure the period of oscillation of a mathematical pendulum using a smartphone. The closest to the average value of t equals 1.731 seconds is the method of determining the oscillation period of a mathematical pendulum using the magnetic sensor of a smartphone with the Physics Toolbox application. According to the determined period, the mass of the Earth is equal to 6.15 times 10 to the 24th power kilograms, which is close to the table value where m table equals 5.98 times 10 to the 24th power kilograms, whereas its density, ρ, equals 5,676 plus minus 64 kilograms per cubic meter. This is 2.9% more than the generally accepted value, which is ρ equals 5,515.3 kilograms per cubic meter. The main result of the work is providing the fact that the use of BYOD technology, in combination with modern measuring tools, smartphones equipped with the appropriate applications, allows solving the problem of distance learning of physics students, as shown by the results of measuring the Earth's mass and density using the BYOD technology. They are consistent with the known values obtained with the help of a more difficult to use and expensive technique. Along with the values of mass and density, the student receives other characteristics of the Earth, the value and slope of the induction vector of its magnetic field, exceeding the mean density of the Earth equal to 5,676 kilograms per cubic meter, according to the results of experiments. the density of the main rock-forming minerals in the Earth's crust, which is in the range of 1900 to 3500 kilograms per cubic meter, leads the student researcher to think about the internal structure of the Earth.
Thank you for watching.
Thank you. Okay, are there any question for Anastasia? Okay, can this method be used to find the Earth's environments?
Yeah.
No.
Unfortunately, it's not possible because each technique and method has its own errors. Somewhere there is an increase in the local density of the Earth. Somewhere there are voids in the mountain massif and so on. The average density is 5500 if the surface of the Earth is covered with the water. It is plus minus 1000, and with rocks, which is 12 50 hundreds kilogram per cubic meter. So gravimetry already solves these issues very well. There is the question is how accurately we can determine the density of the Earth. Our errors is determined by the period, right? That is, the period is used to determine the acceleration of free fall. There is how we determine how exactly we can find the period. We have a lens which we measure with an accuracy of 1 millimeter. There is an error within 1%, and time is even more accurate because we measure it in milliseconds. For example, 10 seconds with plus minus 2 milliseconds is an error of much less than 1%. So the main error is lens. But we can also make it better with some techniques. Yes, unfortunately, we can measure the inhomogeneities of Earth because it's not the same everywhere. Yes, but we can, yes, but we can make more accurate for all density, for main density of the Earth.
Okay, thank you. Maybe we can use it changing magnetic poles, but it only is very big, or not very big. Yes, the several canton.
Yes, it depends to some
Okay.
some things.
Okay, thank you for answer. Maybe there are any questions? Are there?
I want to ask following. What prospects do you see for their work?
Well, we already have the book use of BYOD technology in the educational process in the conditions of distance learning. with more than 50 similar laboratory works, which has already been printed, and will continue in the near future. This summer, maybe we'll print it, maybe new book by several laboratory work.
Okay. Thank you.
Thanks. And
Ivan, yes?
Yeah, thank you for your presentation. We get new ideas on use. Yes, because we have been using this
Yeah.
physical phone experiments for sound. We have developed many experiments on sound just using the smartphone. So we have new ideas on what to do on related to gravitation and the Earth. Thank you very much for sharing your.
Thank you. Yes, we have a lot of some similar laboratory work. If you're interested, it's very cheap. Only a smartphone and some that you can find in your house things. So very cheap and very useful.
Okay.
Yes, I recommended Anastasia and Valery have some several digitals and some several maybe more than 10. Okay, yes, very interesting ideas, and they used it for secondary and for high school students. Okay, thank you, Anastasia.
so
Yes.
our
we
next
finish it, yes, and we finish it from me.
Our next report, it's a report from KRYVYI State Pedagogical University, and the title, Interactive Technology Used During the Study of the Ukraine.
Glad to see you on our conference, and I want to present our topic about interactive technology which used during the study of the universe. Why universe? Because I am astronomy, because I like astronomy, and astronomy is the science about the universe, its structure, its development as a whole, and its object. Astronomy finished to study of all physics branches as well as formation and integrated scientific picture of universe. Universe is a big nature laboratory for demonstrating the use physical laws, phenomena, observation methods, defining physical parameters, different sky object, and teacher must demonstrate it in all the classes. The active use of practical tasks, astronomical simulation, and integrative technologies can also increase interest to the study material and improve understanding physics, nature, and really will form integrating scientific picture of the world. Nowadays, school program in astronomy uses historical approach to its study. Unfortunately, a few hours are devoted to study of the universe issue, and practical tasks are almost not provided. The practical consistent educational material can be realized through the use of application and simulators for computers or mobile phones. It is actually expensive, especially during distance learning. We suggest to use interactive techniques such as interactive online boards, iDream, Miro, Twilio, etc. Online research or interactive presentation, word arts, Answer Garden, Menti, and others. For example, platform I'm sorry for Ukraine because it's a real answer of these peoples. Platform Menti allows to create presentation for problem question. The results can be seen on the screen at once in the form of a word cloud, open answer, a choice of one or more question, and so on. Constant interactive cooperation with the class allows support students' attention and their communication. At beginning of the lesson, such questions facilitate knowledge actualization, checking students' lower of answered of the topic. Problem-based education organization in the end of the lesson. It can be checking of knowledge mastering, the level of understanding and information comprehensions. This research offer uses the interactive technologies during the study of the topic the universe. These technologies were offered to the senior schools students and students of our university while studying in the courses Astronomy and Modern Concept of the Universe. Interactive boards used for more clear and difficult questions, such as what is most widespread chemical element in the universe, what is the size of universe, how is the age of the universe defined, and many other questions, and answer pupil and students finding during the lections. The platform is at Head, Edera, e-learning, and others are completely used as interactive instrument for studying physics, astronomy, mathematics, and other nature science. A significant amount astronomical simulation is offered by the group of astronomers of the University Nebraska-Lincoln. It is more difficult task and can be used for research the universe. The use simulation of the star arrangement on the Hertzsprung-Russell diagram should be used depending on the parameters many other object of the sky. An animation of coins attach a balloon providing an analogy or to the explanation of the university. The coins represented galaxies which maintain their scale while space between them grows. There are many others simulation which was used on our lesson. So, interactive technologies allow to create a more dynamic and interesting environment for the study that contributes to activization of students' cognitive and motivation process. Virtual laboratory enable students to conduct experiments and research in safe and controlled environment. Mobile application and games may stimulate interest in the study and encourage creativity and innovation digital skills. In the research, we have such a service as interactive board for new concept and terms, interactive presentation for actualization and knowledge, frontal questioning, material, and problem-based issue consolidation. Computer mobile application and simulation for practical tasks. The technologies of interactive learning were during distant learning and also during the study of the nature of science in the cases when the real demonstration or experiment cannot be conducted. In such cases, interactive technologies help to use problem-based issues, and the simulation used to realize practical works and tasks. During the study of the universe at the astronomy classes, interactive learning forms facilitate not only students' activization, but also an effective way for forming scientific picture of the world. In the research, it is offered to change the approach to the study of the topic, the universe. It will enable to allocate time for conduction practical tasks, which will be realized through the use interactive technologies and simulations. As a result of the use interactive technologies, indicate that this formula of learning makes students active participants of the education process, increase the level of interrelation between teacher and students, personalize it of the educational process, and as a result, the effectiveness of mastering knowledge, students, and interesting and motivation increase. It develops their critical and analytic thinkings, communicative skills, and skills in the experience their thoughts. This work will be continue for change school program astronomy and use a more practical tests. I am very thank you for attention, very thank you for your time, and if you have any questions, I can answer for it. Okay, thank you for me. And I can
maybe
answer.
I started.
Okay.
In your presentation, you talked about simulators.
Yes.
Why were these simulators chosen?
Okay. When we started many platforms, I was finding simulators for demonstrating physics laws in the universe, and I don't want to use it the star simulators because there are many maybe all simulators, all platforms demonstrated solar system as planet run, why they run. We can choose its parameters in the cosmonautics terms, but there aren't many simulated about the astrophysics, about which we can use it when we study universe. And when I understand that there are problems in the school with learning universe, and these pupils don't understand what is universe, what is law of in the universe, I finding this simulation, and it's have many different topic in the one platform. There are dark black hole. There are maybe velocity star, supernova, neutron stars, stellar, constellar. It all object we can use it for demonstrated physics of the universe. So
thank you for your answer. And that was our last report.
Yes, we finished our work of our section for today and for this year.
We invite to join for next sections for after 2 hours.
Yes. Oh no. Yes. Outdoors.
It's be about mathematics.
Education.
Так.
Yes.
Yes.
Something I see a hand. Maybe anybody want to say anything? Okay, yes, you can. Okay, thank you, Ivan, in your chat, in our chat. Okay, thank you, and you. And we will great to see you in the next section and in the next year.
We will to hope about our cooperation.
Okay.
And
Yes, we can send your work on our conference in IConMaSTEd or the same conference in from our university of our teams. Yes, it's very many conference. And thank you for your time. Thank you for your members, and have a good day.
Thank you.
Thank you.
Thank you.